All right, so we're going to begin with the live coding, the first half, the first two questions of live coding lecture 9. And also, so those are the things that we're going to talk about later. No. Right. So my first comment here is that if you want to write it on your own, that's totally fine. But what my suggestion here is that you can start by playing with the uh, compare mortgage function that's written already in the code, and then just realize that we are not really using that fixed rate with points. So you can sort of comment that line out and just realize that points rate and points actually not utilized, so you can just get rid of those inputs. And then that's going to be a solid starting point. So you don't really need to worry about establishing those payments throughout the period again. So that's making the payments, right? So this part about the for loop. So for each month in the range of the total period, we do payments every time for each mortgage. That's that part of the code. And then now for each mortgage here, we are just printing the total payments, right? Then we then want to manipulate the data. Okay, so here, if you want to calculate the principal at the end of fifth year, 10th year, and etc., you may just want to rewrite the printed data here. Okay, so currently it's printing, okay. Print M is what? Print M is printing the description of your object, right? So each mortgage that the description is actually the legend. So here is fixed 5% or 3.5 for 5 years, then 7%, right? And if you feel that your decimal numbers are too ugly, then you may want to manipulate on your own, because that's the problem of this kind of like scientific computing, in the sense that the flow numbers um, they couldn't really store um, fractions really well. It could be errors. So you may want to, let's say, for printing the names, you can say let's round to two decimals, okay, for the percentage. Uh, Yeah, right. So here, if you see the total payments, we get what? We get the total payments, um, which if you go back to the code is the sum of all the paid amount, right? So for the paid is actually the monthly payments that I'm summing up the entire uh list. Okay. So but now notice here I'm also getting the integral value. So right here, I'm getting the integral value, converting it to a string. So now these are whole numbers. But if you want to round to two decimals, that's also fine. So what I'm trying to do here is that now the print m, right? So I want to, let's say if I want to suppress these decimals, what I want to do is to manipulate the name of the rates. Okay, so this r times 100. But now let's say I round it to two decimals. I'm gonna get a bracket. So round to two decimals. That I'm gonna do it to here as well. So because that's the main problem with the teaser rate and the long-term rate. Okay, round to two. So yeah, if you want to do it in a different way, because in for scientific computing, those numbers you can have multiple ways to get it to two decimal display. So oh, that's the teaser amount. But it's always a good practice, okay, to make your output the way that you want, so that it at least reads better and does not distract you. So let's just make them two decimals. Always make sure to run your code, okay, before you execute the following uh, cells relying on the prior ones. Okay, so yeah, that's what we wanted. Okay, so now we have 3.5 for 5 years, and then 7%. So that's exactly the kind of output that we want. And here, if I want to get, let's say, round to two into cents, right? So I can do that. Okay. All right. So now, we want what? We want, let's slice the um, array of principles and print. Okay, print, not this one. the amount owed after every 5 years are the following. So I'm just trying to make my code a little bit more interpretable, okay? So just print, I need to call a list and then I print it, right? So it's gonna be old. So m dot let me see. M dot old. So that should be my list. But remember the amount owed starting from zero. Zero is the initial principal. So the indices are what? Indices are going to be 5 times 12. Okay. A multiple of that. So it's going to be a slicing of 5 starting from 5 times 12 and colon. And then I'm going to end with 30 30 years. It's going to be 30 times 12. But remember, it doesn't include the endpoint, so you may add a 1. Okay, so, and then it's going to be every 5 years, it's going to be 5 times 12. And let me try to print that. All right. And if you feel that the alignment looks bad, then you may want to give this kind of similar spacing. And um, let me also get it to like a F string, which can be done. Get it space. Yeah. Right. Yeah, make sure to play with them, make sure that the numbers are kind of like correct, because now we are looking at all the same mortgages, right? Um, you can just, uh, yes, be careful. So yeah, if you write it on your own, then you need to be really consistent. So this is the way that I just did is to modify the existing code, right? Slightly. So it's kind of like most this is like the least painful treatment. And the more uh, the more proficient you are with this, then you're gonna freely establish your own. So let me also just scroll back to what we have done. Okay, so it's sort of I just got the loan to be like 500,000. So any amount would be fine. Okay, but then for the compare mortgages, right? For that function, I get rid of the things I don't want, which are the points rate, okay, and the points, so they're not needed. And then I comment out the second mortgage that I don't really need. And then just make sure that the input of the function is consistent with the input that you run. and just verify that your establishment is bug free, and then modify the outputs from there. So this is like a kind of like the step by step, like an incremental um, improvement of your program. And now for the second part, for the second question, for when is the mortgage half paid off, that's gonna be the same thing that I'm gonna do. So for whatever I modified on the top, okay, I'm just gonna copy it down because I know it's bug free, and then I'm just gonna modify from there. So I'm only manipulating the outputs, okay? So nothing else. So that's the incremental method that we are beginning with, okay, for the coding for beginners. So comment these out and yes.
For some reason for lecture nine, not the lot, but for lecture nine, kind of issues around the cells. And I run it, it just stays pinned, it doesn't go through the execute. The check for Gregorian into lecture nine allowed, and this was fine. This might end up with.
You start with the first cell or all the way up from the top. Okay, so do you have anything? Maybe sometimes what about the one on the top? So you started with this one, like the
Should I try to like do it like re-download it?
You may not have to. I think it's box somewhere. Probably not the notebook itself, but yeah, let's try saving your changes and then kill it. Kill it.
Now, we'll stop.
Which one is running now?
I think all
And
of
then
our
let's try pressing the N and see what this one's doing.
It seems to me this one.
Let's let's see what else. That's not all.
It's only for this like live, it's fine. Which means
I think this must be this. Let's just see what we yeah, let's try to use the line. Yeah, I'm not really sure what the problem is. Okay. Yeah, that should be good. Oh, let's try.
this week.
I think this is possible. Is it asking for anything?
Just says like when I hover over this, it just says pending, like it's trying to get it, like it's starting from, it looks like it's starting from here. Here, right?
Yeah,
It's
yeah.
trying to get stuff, but it's not actually moving. Here,
Maybe it's asking for some kind of input, like selecting environment or something. But yeah. Oh, well, I don't think this I don't see any potential issues with the notebook itself though. So yeah, well the problem will not be that. Yeah, if it doesn't help, then try to scale it and then play with the that polling. Yeah, it's there are all sorts of possible issues. So indeed, kind of problematic. Any questions so far about the question one? So yeah, just make sure that for the list that's called old, right? So that's object of old. Make sure to then you're able to call it. And then second question will be really somehow similar. So you're just saying, okay, I'm gonna increase the bounds, right? So initially it's 0, and I'm gonna just check the principal as long as it's larger than one half of the original amount. I'm gonna keep on adding the amounts. But then once it gets below or equal to half of the principal, then I stop increasing the index, but then that index still is going to be the amounts that's less than or equal to the one half of the principal. Okay, so that's going to be the number that you return here. So half of the principal paid off after that month is, so I can also print.
I closed the file and reopened it and now it's I don't know if you sometimes does that sometimes, it just like now it's fine.
Yeah, it's something unexpected that has changed. So, but now once you reopen it, it's just like restarting your machine. So yeah. Yeah. So on the screen now, I'm displaying what I trying for when the principal is half paid off, right? So just increment the index until you um, go below, okay, in the next index. And then also print something to check whether your principal is already reduced to one half or not. Okay. So this is so the output at the bottom is just saying, okay, I'm just reassuring myself, okay, the previous month is gonna be more than 2,500K, and then the next month is indeed less than 2,500. So I'm certain about everything. Okay. Question.
It's gonna be, everything's gonna be fine.
Is it the output? Yeah. It's like if I this it's going up, so two-way twisted. Okay, so we remove the fixed two, but we sort of deleted. Yeah, so two-way should be good. Yeah. Need to be super consistent. Yes. Index out of range. That is like you probably have it done. Yeah, there's another thing. So you need to still start making the payment. So it has to run through all the months before you can actually go with the index searching. So that part is this. Yeah, for all the months, okay, just make the payment. Okay, make the payment throughout the month. So this is something we sort of emphasize that at least in this implementation, you are making the payments outside of your class. But once that's done, it's going to be updating the global variables, namely the lists. Okay, this list which is like the monthly payment in this list of like the amount owed. Oh, so you change this line, so that's the payment routed to decimals. But then for if you want to manipulate the rate percentage, it's going to go to the subclasses. So somewhere here. So these are the legends. Yeah, those are the ones that I modified. I modified this one. I modified this one. And that. Yeah. So yeah, it's optional, but just make sure that the list that are callable, okay, for your conversion. You will find out. Still numbers still environment. Okay, right. But total payments are. Oh, that's huge. Yeah. Cities, 9% Israel, people. And I have the total payments. Yeah, and then Jim, I have things. Yes. But we think is outside of the boundary, right? Then what's yeah. Oh, okay, that's okay. That wait. Notes. Because you oh yeah, you probably want to put them inside because you want every mortgage to be computed, right? And I also wonder, yeah, let's run and see. What's really large? I don't know, it's only stick. Is it 1 million? Oh, yeah, $1 million more. Yeah, yeah. So you come in now and so you never. Yeah, that's fine. That's fine. Yeah, the wish to expect it. What's did you do it again? Okay, so yeah, comment this out. Yeah, usually you have M, you did the payments for all the months, and then for N, the months you did again. Did it again. Yeah, so this is a longer list. So that is the. Yeah, so that's yeah, okay. Thank you. Yeah, you need to be really careful. So which is why I'm saying copy the code from the older lecture notes, and then you can sort of like reduce the number of lines to be edited. But yeah, make sure to make the payments for once. Um, yeah, that's pretty interesting. So in fact, in your code, it's like the duration becomes 60 years.
Yeah, compounded twice as long.
Yeah.
It's ran 30 twice.
Huh. Yeah, that's pretty interesting. All right. So yeah, that's first two questions. Right. And then yeah, for the retirement, basically it's really similar scenario, but you need to modify the code a little bit. So yeah, you can also start from scratch. But yeah, let's now look at the matplotlib to finish up what we left off from last time. So in the end, you would want to get a plot for. So yeah, it's the idea here is that okay, I have we have a retirement age, let's assume to be 70. We retire at 70, and then we may assume that we live for another 15 years. So for each of those years, we need to have, let's say, a certain retirement payment, let's say 50,000 to spend in each year. Um, and then basically that's gonna be like a retirement saving, okay, at the time that you retire. So then you would want to program to compute, okay, that's duration of years I'm gonna live after retirement, and then multiply by each year how much that I need. So that will be the savings that I sort of target at. Okay, that's going to be like 7,500,000. And then I need to sort of build up the retirement savings by putting M dollars in the stock market and assume we have R percentage of return every year. So it's going to be M in the first at the end of the first year, and then that's going to accrue interest of 1 plus R, and then plus the next payment, and it just continues. And if you look at the sequence here, it's actually, yeah, the index is, it should be a W minus 1 and W minus 2 all the way down to the power of 0. Okay, so it's W minus the power of W minus 1, W minus 2, there will be W times, right? So W is, W is the number of years that you would work. Okay, so where's W? Okay, W is something you need to define. So basically you start, let's say from the first year, you're gonna have your dream job and you're gonna stay there forever. So it's gonna be until you retire, right? So that will be total number of W years. So so yeah, eventually the savings is gonna be this value. Okay, so the last year it will not compound, but then every other year is gonna compound, and then in a sense, so eventually you want to solve for M, right? So each year, how much you would want to invest. And then it's really similar kind of equation that you want to set up, which is the total savings that we calculated above, right? Dividing by this sum, which is, again, a geometric summation. Okay, so to modify the find payment function from earlier slightly, that will give you the monthly payment for this kind of problem, okay, retirement problem. And then here basically it says, okay, I initially have like a return of 5%. What's going to be my monthly payment? And then let's change it to 7% of return and the 10% of return and see what different payments would I need to make for throughout my employment, right? So those are some kind of like a starting point of this task. And then that's sort of like three different kinds of investment plans, right? And then later we need to do the plotting. Okay, we need to import matplotlib pyplot as plot plt, and then we're gonna construct the list of my savings. Okay, so it's 0 at the beginning. Okay, but then every year it's gonna accrue the interest 1 plus R and then add with the current payment. So this is what you would want to the way that you want to set up your savings as a list. Okay, but then of course this is outside of a class. My recommendation here is that play with a class. So for each investment, make it as a class class object, and then you change the parameter that will give you a different class, which has a different list, right? And then here finally plot. Okay, plot the comparison of the three retirement plans. Eventually, they will begin with a zero at the beginning. There's nothing in the saving, but then eventually they all hit to, let's say, 750K, right? But then there will be three different curves in the same graph. All right, so that's what we are sort of expecting. Now for the plotting, okay, so let's look at the plotting part. So where were we? We were talking about, okay, so let's look at the so yeah, we have done this part, okay? So in class exercise, and we actually covered up to, okay, the plotting of the mortgage class. Okay, so this is very interesting. So I'm gonna convert back to the notebook, OneNote. So
Professor,
yes,
for that loop you wrote,
let me turn up the volume a little bit. I cannot really hear you clearly. Wait. Oh, that's crazy. That sounds. Could you speak up?
yeah, so I have a question
Yes.
about the loop you wrote.
You have a question about what?
The loop you
The loop.
wrote, and yeah, I think it was on the previous page.
Oh, let me try this. So I probably don't want to. Let me try and see if I can turn up the volume from the computer side and see if it hurts. Hello?
Yeah,
Hello?
I can hear you fine.
Okay, yeah, it's okay, so what's the question?
So the loop you wrote, right? I was writing the definition for that, the function for that, and can you help me understand how can I write a function instead of putting the same thing in the loop?
You are talking about which notebook? The live coding or the
The
class
live
notebook?
coder.
The live coding.
I think even in the class notebook we have it. That's okay.
Yes.
Yeah, for I in the range years plus one. Um, how would you put that same thing and define it as a function so that I can every time just change the principal amount, not the principal amount, the amount mm, change the principal amount.
Mm, you're talking about this line or what you're trying to change what?
For that same loop, I was thinking to not write the loop and to
Yeah, let's go back. Let's go to the specific line that you are talking about. So, if you want to share your screen, I'm totally fine. I think we are able to share multiple screens. So let me stop sharing my screen and you can share yours.
um, I think can we discuss this after class? It'll be
That's also
easier.
fine. But
Okay.
yeah, it's just I do want to know what line you're looking at. Okay, so yeah, so let's quickly look at what we try to do for the plotting. So earlier we said, okay, plotting the mortgages, what you can wait. Okay, yeah, we are here. So if you want to simply plot a sequence, okay, what can you do? So we have interest rate of 5%. Okay, we have 20 years. So every time this is like a simple compounding. This is basically saying I have a values as the list, which is empty, but then every time I'm gonna append the principal value. Okay, so basically the first time you will append what? It will append 10K, and then it will the principal would add. So what does this line do? So this line does the principal equals to 1 plus R times the principal. So yeah, it's principal times R, okay, plus P plus P times R. So this is actually P times 1 plus R. So if you want to get indices, it's going to be what? It's going to be pk equals to pk minus 1 times 1 plus R. Okay, so that's the thing that you're appending. Okay, so this is going to be what? It's going to be 10k times 1.05 and then 10k times 1.05 squared and all the way up, right? So that's what this part is doing. So this is just constructing you a geometric sequence. And then what do you do with the plot? So the name of the figure is this, okay? This is the name of figure, which is just the figure name. The name of the figure is fig equals to plot dot figure. So basically, it's just saying, okay, in the package, I'm just calling the method a figure. This is constructing a figure, and I'm giving it a name, which is fig. And then now I'm going to plot values. Okay, the values is what? The values are the geometric sequence that I constructed. And then I'm going to give a title and the descriptions of X and Y labels. All right, so this is really standard. So these are sort of, if you really think about the graph, so even if you get rid of the title and the XY labels, that's totally fine. So once you do plot plt.figure, it will give you a figure. And then based on this plot, you will be able to plot a bunch of sequences. So this line here is to plot the sequence which is constructed from the values. And of course, let's say in our mortgage class, right, we have the paid, we have the self.paid and self.owed, right? So these two are sequences that you can both plug into the same figure at once. Okay, so just like the sine and cosine functions. But yeah, so that explains what you see in the coming up figure, which is so to quickly indicate what they are. So the Y label goes here, the X label goes there, the title goes here, and then the values are just the values that are being plotted. They are the blue curve. All right. So how many data points are there? There are 20. Okay, but let me see. From 0 to 20. Oh yeah, it's 21 points. So 21 data points. All right, makes sense. So yeah, so so those in brackets, they are sort of like necessary things for you to make your figure look nice. Okay, but they're not required. Once you do fig equal to plt.figure, that will give you like a prelocated sort of memory for the figure. And then for every time you do plt.plot, that will plot something into that figure. And then it could accumulate. It could be like 10 curves within the graph. So that's really common in like scientific research papers. They'll have different curves that they are trying to compare. Okay, compare certain performances. All right. So yeah, that's the starting point here. And now augmenting the mortgage class. So if you look at the code, nothing has actually changed. So we are now looking at the same mortgage class. So that's the initialization, nothing changed. We are doing the make payment, get total payment, and also the print of my object is going to be the str function again. It's printing the legend of my mortgage each time, right? So they are same. They're the same. So now what are these? So these stars, code cells, they are changed. Okay, they are additional. They're new. So basically, what do? We just need to plot the payments So that's going to be plotting the monthly payment in one graph, in one figure. Okay, so you see that that's here. We are now looking at the plt.plot method. Okay, so basically later you're going to see it's going to be a figure of payments, and then you're going to plot all the curves. Okay, all the curves from different mortgages, all about payments into one plot. Okay, and then all about the remaining balances. That's going to be in another class. In another plot, and then for the total amount paid, it's going to be in the third figure, and finally we have the net um, mm, kind of like the net worth. Okay, so right, so let's see. The payments, yeah. So directly plotting the payments. So I'm just ignoring. So this is ignoring the initial payment because initially I haven't done anything. All right. So especially for the fixed term, so I'm not paying anything at the beginning. So if you buy points down, there will be a payment, but that's going to be really large. So we don't really consider that in our comparison. Um, and let's see the balance. Yeah, the balance is the remaining principal. Okay, so this is the self that owed, right? So the self that owed. So yeah, these are so yeah. Just make sure to go back to look at these code. But basically, this style is the style of your curve. Okay. So basically, it's like every mortgage you have a style. Okay, so this is per each mortgage. And then of course the label is going to be yeah the label is also needed in the sense that later there will be a legend in the figure so indicating which curve is which. Okay, a label is also sort of required. Mm, the total amount paid. Okay, so the total amount paid is the cumulative total of payments made. So it's going to increase all the way up to uh the total amount of loan plus interest accrued at the end of time. All right, so it's gonna increase all the way up. So, but be careful. Remember, we have three different kinds of mortgages. One of them is like a teaser rate plus a larger rate, right? So that's a little bit different. So you cannot really directly utilize the initial payment plus a geometric sequence as a formula. So here what we do is every time I'm just accumulating the self that paid. Okay, so the total amount paid, the last entry I'm gonna add with the current payment. So this is sort of like accumulating the payments instead of using a explicit formula. All right. All right. Okay. Net. So plot net. This is something also interesting in the sense that it's helpful if you are comparing the mortgages. So I'm gonna allow you guys to read the code below to understand exactly what's going on. But basically, read the description right here to see what this is doing. So this is the total cost of the mortgage over time by the cash expended minus the equity acquired. So basically, this is just saying, okay, we have a certain amount that's been paying off the interest. Okay, so the loan will accrue interest, and you are making the payments. And the payments are partly paying off the interest and partly paying off, and it's reducing the principal. Okay, so this is basically a way that you somehow calculating how much you have sort of spent on paying interests. Okay, so right, so these are four plots we're gonna establish. So at the bottom line, we have four different sequences. We're gonna put into four different figures. Okay. All right. Now, okay, the classes they are not touched at all. Okay, and then right. this function plot mortgages. So basically we have the input as different mortgages. Okay, so these are different mortgages. And then here we have styles. So if you look at this styles, we have three. Okay, so we have three different mortgages. And basically we're just saying, okay, I'm trying to get three different styles of my curves, one for each mortgage that I'm gonna calculate. Okay, list three styles for three mortgages. So if you really want to know what these syntaxes mean, so this is just blue, blue, and blue. So they are B's, and then we have a minus, we have a minus dot, we have a colon. So there are different types of curves. Okay, in terms of like so this is the minus or that's just a continuous curve. And then if there's a dot in there, they're just saying it's gonna be line dot line dot line dot. And then for colon, it's gonna be just dotted curve, right? So different kind of line style. And then okay, so now this part, okay, this part is just giving names to each figure. So just making the names reasonable. So because we have four different curves that we're gonna different figures we're gonna establish. So there's the comparison of payments, that's gonna be my figure 0. Comparison of costs is gonna be my figure 1. Comparison of balances, remaining balances is gonna be my figure 2. And figure 3 is gonna be the net cost. Okay, it's just the amount spent on paying the interest. Right. So now, if you look at these brackets that we established below, so what do they mean? It just means, okay, for figure 0 about payments, remember payment equals to 0 because that's 0. So for figure 0, I'm gonna give a title X label, Y label. And for the figure 1, I'm gonna give another set of title and labels. And then for figure 2, okay, so the balance is equal to 2. For 3, so figure 3 is going to be net cost. Make sense? And then here, if you look at the code below, it's really systematic. This is just saying, although we have a bunch of like inputs in English, but they're essentially just numbers. So this is saying, okay, plot 0, I'm gonna plot each I'm gonna do plot payments, okay, for each mortgage, all right. So for mortgage I, I'm gonna plot payments within my 0 figure, and this is my figure 1, this is my figure 2, this is my figure 3. Really systematically. And later, when you are trying to plot the for the investment for your retirement, right? It's going to be one graph. Then you may not need all these figures, but then it's going to be setting up one figure, getting a bunch of retirement plans within one figure. So it's going to be a really similar procedure. And finally, there's what's called the legend. So legend means you have the description of the curves, but you want to place it somewhere in the figures. So you don't really want the curves to overlap with the box of the legends. So that's just something you need to be really careful about. Okay? So those are the location. Okay, so this is my curve 0, curve 1, and curve 2. Okay, so for 3 of the figures, we specify the legend. Okay, so legend box. Right. So now, how does it look like? Yeah, just notice here. We just do plot the mortgages right here. Okay. So nothing has changed except we are just doing the plotting. So everything above, they are pretty much the same from before. Okay. So you see, we have what we have total months, and then three different mortgages, and we have a list of mortgages, and then finally we do the payments, right? So payments. So morts. Okay. So yeah, I need to get a bracket here. So they are not changed at all, right? And how do they look like? How do they look like? They look like this. So if you are looking at your notebook from your laptop, make sure to run this. The figures may be larger than what we display on the screen right here, but essentially, this is my figure 0. This is my figure 1. So remember, figure 0 is the payments. So if you compare, remember we have B, we have this is the style B with minus sign. This is a style with B minus sign and a period. And this is style with B minus colon. So colon is going to be just dashed curve. Okay. So minus with a period, that's just uh, kind of periodic changing. Okay. So minus dot, minus dot, minus dot. So yeah, different styles and different color. So yeah, different kind of payments. So here we can see, okay, for the teaser rate, it will give you like roughly speaking 1,000 monthly payment for 4 years. Okay, like 48 months, and then all of a sudden it jumps to 1,600 ish. And you can see, okay, your legend is overlapping with the top curve, which is something you may not really want. Okay, so you may want to modify your graph a little bit so that your large legend usually does not overlap with your plots. Okay, and then you can see something that's also similarly happening in my following up figures. So we have the figure 1, 2, and 3. So yeah, well, the remaining balance is always from 20 to 200,000 dropping down to 0 throughout the 36-year period. But yeah, that's the remaining balance. And the net cost is basically sort of like how much interest you have paid throughout the time. All right, and you can see, and then that's gonna be the main comparison, right? So the dashed curve is actually the 2 rate, which is eventually making you to pay more interest, okay, throughout the time. And then the fixed rate gives you a little bit less net cost. And finally, if you make the payment down and by points, then that interest rate is so small that the final interest is much less comparing to the other two. So that's what which you can do to sort of compare through these plots. Um, so So yeah, well, one thing I like to sort of emphasize here is that we have what's called the legend, right? So that's upper center, okay? So that's upper center. The other ones, they're the best. So best is just saying, okay, they're gonna they're gonna find the location to put the legend so that it's not overlapping with curves, okay? But it may not be optimized. So if your best visual um, for the best visual, you may want to choose your own kind of like a location for the legend. Right. So this is the upper center. Okay. As a string. Right. So yeah, well, I would say, of course, you can change the colors of the curves, right, to make it look better. And then we have the curve styles, but there also can be marker styles. There could be like for each data point, there could be a cross, there could be a square, there could be like diamonds. So depending on your preference, especially if you want your the curves to be distinguishable, especially when you have like five curves or like seven curves within the same figure. Okay, you want to sort of distinguish the overlap. So yeah, there are all kinds of options for the Matplotlib. But yeah, try to explore and see what you can do to play with them. So in the live coding, I'm gonna also introduce so changing the X range, changing the Y range so that the plots looks nicer, okay, in certain ways. But yeah, so those are sort of what you need, okay, to complete the live coding for the retirement plan. Any questions so far? So yeah, so utilizing packages. So that's something you sort of have to practice a little, okay? So the key idea here, I would say the takeaway is like this, okay? So you sort of need to study this plot mortgages function. So it's really systematic work. So if you want to get a label as a number, okay, so basically it's like figure zero, figure one, figure two, figure. So the inputs of the figure of this figure of method is going to be an integer, okay. So that's kind of natural. Like in papers, you have figure one, figure two, figure three, right? So those are kind of really systematic. But then give a label, and then that tells you basically every time you can call that figure and then add plus, add points into your figure, right? And then so set up the plot using plt.figure, and then set up the title, the XY labels, and then what do you do? And then you move on to getting the plots, okay, into the figure. Okay, so that's my um, plot, figure zero. I'm gonna plot mortgage one, mortgage two, mortgage three, using plot payments, okay, and using the style I. So this is the way that you systematically make all, the different curves into a plot. All right, so yeah, let's go to the live coding. Yeah, right. So so on my side, I re-executed the code a little bit later. So if you look at the display now, the figures look much larger than the original notes that I have in the printout. Okay, so yeah, well, live coding. Hmm. Okay, so let me see. We have current age of 34. Okay, so current age is 34. Retirement age is W. The number of years that you're gonna invest is gonna be the retirement age minus current age. The rates are gonna be point 0.5, point 0.05, point 0.07, point 1. And yeah, I'm gonna write the function m. So let me copy the things from top so I can utilize. So you guys can make sure to play with it. But basically, I need to get the data altogether. Of course, current age, and I need death age. So those are the inputs that you want to change, right? So my recommendation here is that write your payment function first, which is not difficult by looking at the formula right there. And then think about writing as a function so that we can reuse later. Because once again, you're gonna have three different retirement plans, and then you need to plot three curves into one figure. Okay, so that's the end game of this question. So you may think about making it manually. So yeah, so the easiest or the layback way is okay. I construct three sequences, three lists. So list one, blah 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 blah, a bunch of numbers from 0 up to 75, 750K, right? And then curve two, I have a list two, I have a list three. So then plot the three lists into your figure and then done. Okay, so that's one option. But then the other one is that I can try to do dynamically, similar to what you have done, what you have seen in the mortgage class, right? So yeah, just make sure you spend some time playing with that. Okay, so here I'm copying the data down so that I don't need to do it again in the future. So I have, okay. So I'm gonna write the function. M is the monthly payment. So define the function. Find investment. Find them. Investment. Invest. Okay, so yeah, any function name that you want. It's gonna be what? It's gonna be relying on savings and interest rate and W. Okay, R and W. And I want to return. Let me see. It's gonna be savings over savings times R over yeah, if you look at the code, the formula is wrong, but yeah, to the W, then -1. And make sure to double check that's correct. Okay, so you just simplify this expression, which is what? Which is 1 plus R to W -1 in the numerator, divide by 1 plus R minus 1, which is R in the denominator. Okay, so then you rearrange. So savings times R over okay, that's that. And then call the function. I'm gonna print M. I'm gonna print the list. Okay, print M. For R in. All right. Let me run this one. Retirement play. Retirement pay. I need to do this. Yeah. That should be it. All right. So yeah, that's pretty much it. So basically, it just says okay for different interest rates. Well, investment return. I'm gonna have three different monthly payments. It's gonna be 7,000 something, or 5,000 something, or 2,500 something. Okay, which are significantly different. right? And then basically you can start constructing the lists and then doing the plotting. Okay, so yeah. So that should be a good starting point. So yeah, of course, if you want to just capture the figure of this cell and then starting from that, so starting from there from next time, that's totally fine. Um, right. I would say yeah, play with this for some time because we have assigned the homework which involves this kind of question. So which is the last homework of the semester. Yeah, let me stop recording and I'll see you guys on Monday.